All right, adding and subtracting rational expressions. So this is day 2. This is like simplifying rationals and multiplying and dividing them, but just taken to the next level. So we have a little bit more that we're actually doing here. Okay, some vocabulary as usual. So a complex fraction is a rational expression that has a fraction in its numerator and denominator, or both. So, or I said that weird, numerator or denominator or both. So like 3 over 2 over 5. That's a complex fraction. Or x minus 4 over x over 5x. That's a complex fraction. So it's just like a fraction within a fraction. Okay? And then the least common multiple is the product of the prime factors. So like if we look at 12xy squared and 15x cubed y, you get those to their primes. So 12, the prime factorization of 12 is 2 times 2 times 3. We have the 1x and we have the 2y's. The prime factorization of 15 is 3 times 5, and then we have the 3x's and the y. So the least common multiple there would be 60x cubed, because you have to look at all the, I'll get into that more. We're not going to go in depth with that right now. Okay, so the least common multiple, you should have heard that term before. Adding and subtracting fractions, you have to get the same denominator. So I would just write this a over c plus or minus b over c is the same thing as a plus or minus b all over c, because it has the same denominator. That's the same as like when you just add fractions normally. So if you had like 1/9 plus 4/9, that's the same thing as 1 plus 4 over 9, which is 5 over 9. I don't know why my 9s look like G's, but that's all it's saying, okay? No, not that. And then if there's different denominators, you have to get the same denominator first. So if we have a over b plus or minus c over d, you have to multiply that first fraction by d over d, the second fraction by b over b, and you're left with ad plus bc plus or minus bc all over bd. Okay, hopefully that kind of makes sense. We'll get into it more, and I think it will. So first, we need to practice finding least common multiples of polynomials. So if we look at example A, the first thing you do is factor all the polynomials as far as they can go. So the 2x plus 4 factors to 2 times x plus 2. X squared minus x minus 6 factors to x minus 3, x plus 2. Now we're going to first see what I have in common. So we have the x plus 2's in common, and there's nothing else there in common. I'm going to pull down that x plus 2. And then I'm just going to pull everything else down with it. So we have the 2, that comes down. We have the x plus 3. I've used everything now. That is my least common multiple there. Okay, you just have to use everything, and if we have pairs of something, we just pull out one of them. Okay? Let's look at B. Again, we're just going to factor all of these. So x squared plus 3x minus 4 factors to x plus 4 and x minus 1. X squared plus 2x minus 8 factors to x plus 4 and x minus 2. And x squared minus 4x plus 4 factors to x minus 2 and x minus 2. Okay, here I'm just going to see what pairs do I have in common. So I have my x minus 4's, and I have my x minus 2's. Those are the only pairs. You can only look at pairs. Okay, I know I have 3 x minus 2's, but I'm just going to take 2 of them for now. Okay, so I'm going to pull out my x plus 4. I'm going to pull out my x minus 2, then I'm going to look and see what do I have left. I have x minus 1 left, and I have x minus 2 left. So that is my least common multiple. Okay, so x plus 4, x minus 2, x minus 1, x minus 2. Now let's use this. So when we're adding rationals, you first need to find the least common multiple of the denominators. So basically we need to factor the denominators. The first one is factored. X minus 3 is factored. X squared minus x factors down to x and x minus 1. So I'm just going to write that down in the factored form. So my least common multiple here is x, x minus 1, and x plus or minus 3. That's my least common multiple. So now I need to get these to have the same denominator. Wait a minute, go back. Before we do that, we need to state our restrictions. Okay, So you have to see what do I plug in for x to make this equal 0? X cannot equal 0 because of the first x. X cannot equal 1 because of x minus 1. X cannot equal 3. Don't forget to state restrictions like I just did. Don't do that, okay? Don't ever forget to state restrictions. Those are very important. So once you state your restrictions, now we're going to find a common denominator. So the common denominator is my least common multiple. So I have to look. I'm going to look at my first fraction, so the x plus 1 over x minus 3, and see what am I missing in the bottom right there. I'm missing x times x minus 1. So I'm going to multiply the top times x minus 1 and the bottom by x times x minus 1. I'm really just multiplying that rational expression by 1, but I'm doing it to top and bottom and making this so I can add these together. Okay, the second one is missing an x minus 3. So I'm going to multiply that second expression by x minus 3. Then we're just going to go through and we're going to multiply this out. So I have x times x minus 1 times x plus 1 over x times x minus 1 times x minus 3 plus 2 times x minus 3 over that same thing. And before I can combine these, I need to multiply each individual one. Not the denominators, the numerators. We're going to multiply them out in the top. So x minus 1 and x plus 1 combine to be x squared minus 1. You can use the box or distribution there. And then 2 times x minus 3 multiplies to 2x minus 6. And last thing, I'm just going to multiply that x in. So I get x squared minus x plus 2x minus 6. Now we have the same denominator, so I can just combine like terms there. So I have maybe x squared minus x plus 2x minus 6. Combine those x's, and you get x cubed, I said squared, I meant cubed, x cubed plus x minus 6 over x times x minus 1 times x minus 3. And I want you to leave that bottom in its factored form. Just leave the bottom factor, don't factor or multiply that back out. Okay? At this point, you would usually check to see if the top will factor. In this case, it won't factor, so we're done. Okay, we're going to save example B. If you got lost in there, go back and rewatch this. Okay, let's go on to subtracting rationals. Subtracting is essentially the same way as addition. We just have one extra step. And I bet you could guess what this extra step is. But the first thing, again, we're just going to find that least common multiple. So we're going to factor both our denominators. X minus 2 is already factored. The x squared minus 3x plus 2 is not factored, so that factors down to x minus 2, x minus 1. Okay? So the least common multiple here is x minus 2 and x minus 1. Now I just need to see what is my first fraction. Oh my gosh. Don't be me. Don't forget to state restrictions. I've forgotten twice. So that means that you guys should forget 0 times. Okay? Sorry. Don't forget to state restrictions. So at this point, when you find your least common multiple, you state restrictions. So x cannot equal 2, x cannot equal 1. Do not forget. Don't be like me. Don't forget to state restrictions. Okay? So x cannot equal 2, x cannot equal 1. Now we're going to get the common denominator. So I have to see what is that first fraction missing, what is the second one missing. Whoa, what just happened? The first one is missing the x minus 1. So I'm going to multiply top and bottom by x minus 1. The second one is not missing anything. So then I'm just going to go through and I'm going to multiply that out. X minus 1 times x plus 3 is x squared plus 2x minus 3. And then the 6x minus 7 just stays the same. At this point, once you have multiplied it out, you've gotten the same denominator, you have stated your restrictions because you didn't forget, this is when you're going to distribute that subtraction sign. And that subtraction sign only distributes to the top. So it changes to a plus, and that becomes a negative 6x and a positive 7. So at this point, after you have multiplied everything out, you've stated your restrictions, you have found a common denominator, that's when I want you to distribute that subtraction sign. Okay? Now this is addition, and we're just going to combine like terms. So we have x squared plus 2x minus 3 minus 6x plus 7 over x minus 1, x plus, or minus 2. Combine like terms on the top, you get x squared minus 4x plus 4 over x minus 1, x minus 2. Now that x squared minus 4x plus 4 can factor, so we need to factor that. And that factors down to x minus 2 times x minus 2, and then the x minus 1, x minus 2 stays on the bottom. Then if you notice here, we have an x minus 2 on top, we have one on bottom also. So those are going to cancel, and you're just left with x minus 2 and x minus 1. X minus 2 over x minus 1. And that is your final answer. Okay. Lots of steps, you just need to be very careful, be very organized when you are doing these problems, okay? Even like on your homework, I know those boxes are kind of little. Use a different paper to do it if you need to stay organized like I do, okay? We're just going to go over a couple more things, simplifying complex fractions, and I'll try and do this fast. Okay, so we need to find the simplest form using either method. So there's two methods here, and I'm going to show you both. You can choose which one you like more. So the first one, we're going to simplify the numerator and the denominator separately. So I'm going to separate my numerator and my denominator. I have x plus 1/2 and x minus 1/7. So I need to make that into one fraction. So on the x plus 1/2, the 2 is what my denominator is. So I'm going to multiply the x by 2 over 2. And I'm going to get 2x over 2 plus 1/2. Those 2's are the same, so that just becomes 2x plus 1 over 2. And then you're done with that step. Now we're going to do it to the denominator. So the x minus 1/7, I need to multiply that x by 7 over 7. Then once you do that, you'll get 7x over 7 minus 1/7. Now we have the same denominator, so that's just 7x minus 1 over 7. Now we're going to put those back into the complex fraction. So we have 2x plus 1 over 2 over 7x minus 1 over 7. This is the same thing as a division problem. So that's 2x plus 1 over 2 divided by 7x minus 1 over 7. Remember, when you divide, you flip the second fraction and you multiply. So that's what I'm going to do. 2x plus 1 over 2 times 7 over x minus 1. Multiply that out, you get 7 times 2x plus 1 over 2 times 7x minus 1. Nothing can cancel, nothing can simplify. So that's the final answer there. That is the first way to do it. The second way to do it is we're going to find a common denominator between the denominators in my numerator and my denominator. So the only denominator I have in the top part of this fraction is 2. The only denominator I have in the bottom part is 7. So I need to see what is the least common multiple between 2 and 7. It's 14. That's the only thing that, or not the only thing, but that's the smallest thing that 2 and 7 go into. So I'm going to multiply everything in this fraction by 14. I'm going to multiply the top by 14. So I multiply the x by 14, the 1/2 by 14. On the bottom, I multiply the x by 14 and the 1/7 by 14. So you just multiply everything by that common denominator. And then you just multiply this out. So 14 times x is 14x. 14 times 1/2 is 7. Then the bottom, 14 times x is 14x. 14 times 1/7 is -2. Well, it's a negative because there's a subtraction right there. Now I'm just going to factor this. So on the top, I can factor out the 7. So you get 7, 2x plus 1. On the bottom, you factor out a 2. You're left with 7x minus 1. Those are the same exact answers. So you get the same answer either way you do it. You just have to choose which one you like more. Okay, that's all for this video. Sorry it's long again. I know we only have 2 videos this unit though. So we are going to do a big review of all of this next time. Then review, then test. So we have like 3 days until the test. But it is kind of a lot packed into a small unit. So please make sure you took good notes on this and ask questions in class tomorrow. Okay, and I will see you then. Don't forget to take the quiz.